ADSC, the International Association of Foundation Drilling, joins with your company to emphasize the critical importance of safety in your workplace. You must never forget, workplace safety can literally be a matter of life and death. What are micropiles? Micropiles are a reliable pile system that can withstand large capacity axial or lateral loads with minimal disturbance to existing structures. They have become very popular due to their ability to transfer loads efficiently through skin friction and due to their many installations advantages over conventional pile systems. The first use of micropiles dates back to the early 1950s in Italy, where new methods of underpinning for existing structures were needed to restore structures and monuments damaged during World War II. Dr. Fernando Lizzi is commonly recognized as the inventor of micropiles. What is anchored earth? Tiebacks, also called ground anchors or simply anchors, are devices used to support retaining walls. Anchoring in the ground is typically achieved by boring a hole in the soil or rock and encasing a portion of the tendon in a grout mixture. The tendon is anchored into the ground at the depth of the tieback and to the face of the wall under tension. In 1934, high-capacity anchors were installed to stabilize the foundation of a dam in Algeria. This project represented the first major application of ground anchors. After this success and the introduction of high-strength steel and improved grouting techniques, ground anchors grew in popularity in several countries in Europe and eventually in the United States and Canada. The anchored earth and micropile drilling industry is inherently dangerous. Every day, you and your fellow employees are at risk. The potential for injury and even death clearly exists. And you must be aware of this fact with every thought and action. Working safely must be your #1 priority. Safety isn't just a slogan, it's a way of life. In the next few minutes, we will look at a number of specific job-related hazards and how to control them. The purpose of this presentation is to highlight major risk areas and to help you realize that situations you may take for granted can, in fact, be the most dangerous. Remember, safety, along with quality and productivity, is your goal. Even a minor oversight of a safe working procedure can have devastating results. Whether you're a seasoned veteran or a rookie new to the project, you should not underestimate or ignore a high-risk situation just because it is familiar to you. It can be the worst safety decision you'll ever make. You must take the initiative and always work above a reasonable level of safety. Remember, when you gamble with safety, you bet your life. How safe is your work environment? The answer is a function of 3 distinct considerations. First, knowledge. Training is the key to knowledge. Fundamental safety training will give each employee the knowledge to recognize potential hazards that exist during the micropile or anchored earth installation process. The use of personal protective equipment, proper lifting techniques, the use of a fire extinguisher, and other basic training is important to every employee's safety in the workplace. Hazardous materials and chemicals are present on anchored earth or micropile projects. Gasoline, diesel, oxygen, acetylene, grease, welding rods or wire, and cement are just a few examples. Employees must learn the proper procedures necessary to handle these hazardous materials. Specific information about the hazardous materials on site must be readily available to employees. One source of safe handling information is a Safety Data Sheet, or SDS. Each employee must know the location of the data sheet and how to understand the written information and symbols. Emergency procedures must be in place at every job site. Employees must know the location of posted emergency phone numbers and the location of the nearest medical facility. Emergency procedures must be understood by each employee. Near-miss incidents should be reported so the conditions are corrected to prevent the incident from happening again. In the event of an actual injury, report it to your supervisor according to your employer's safety policy. A micropile or anchor drill rig operator must be trained on the safe operation of their drill rig in accordance with the requirements of the manufacturer, their employer, and all local, state, and federal agencies. Do not attempt to operate any hydraulic, pneumatic, or electric-powered equipment unless you are fully familiar with all the gauges, control functions, and operational sequences. Basic drill rig safety information can be found in the ADSC's Anchor and Micropile Installation Safety Guide. This booklet can be used, in addition to the employer's safety program, to help ensure each employee is trained on how to perform their job safely. Additional safety training for project managers, field supervisors, foremen, rig operators, and general crew members consisting of OSHA or other government construction safety and health training is highly recommended. This intensified safety training is available through your local ADSC chapter membership. Company-based, task-specific training on subjects such as working around the drill rig, mixing and pumping grout, handling drill steel, and other topics related to the job at hand should be performed for each new employee before they begin work. Daily pre-task safety and production meetings along with the general weekly safety meeting are great tools to reinforce the employer's safety policy and safety training procedures. No employee should have to guess as to what a procedure is, and with the proper training, no employee will ignore a hazardous situation. They will, in fact, correct it. Human nature dictates that the higher your comfort level is with a particular job or activity, the more complacent your approach and effort will be. Remember, complacency is the enemy of safety. Safety should be built into your daily activities, not added on later. The daily work habits of every employee on a job site must incorporate safe productivity at all times. Your employer has the responsibility to ensure that the work environment is free of recognized hazards. However, it is the responsibility of every employee to make sure that their own work habits are safe as well. No other possibility can be permitted or tolerated on your job site. The final consideration is you, the individual. The bottom line is that every individual must work safely. How you are feeling and what you are thinking are critical to the safety formula. For example, if you are overly tired, sick, or upset, it is impossible to concentrate on working safely. Working safely demands your constant awareness. And awareness can only occur if you are alert and focused on what you and the others around you are doing. Drugs and alcohol are strictly forbidden and will not be tolerated. On-the-job safety is a team effort, and you are part of the team. If you see a potential hazard, you owe it to yourself and to your fellow employees to do something to minimize, or better yet, eliminate the hazard. Do not simply ignore it. Getting everyone focused on safety needs to be the first step of every day's work activities. It can be handled in just a few minutes, and it is time that will reinforce safety awareness as well as create total work efficiency. Every supervisor should have a written checklist to follow and complete with the crew before starting work for the day. All equipment, supplies, and tools should be checked daily to make sure they are in safe, working order. A quick check at the start of the day ensures that the right tool for each job is available and that it is in proper condition. This process will minimize downtime later. Slings, shackles, chains, hooks with safety latches, and wire rope should be inspected to ensure good operating condition and that each has sufficient capacity to do the jobs that will be required. Any item that is not in the proper condition should be tagged out of service, fixed, or replaced. Do not use it. Hand or power tools, as well as power cords, must be inspected prior to use to ensure safe working order. The correct personal protective equipment is a must for worker safety. At a minimum, all workers must have a hard hat and safety glasses. Work gloves and sturdy work boots or shoes are essential. Consult your employer for any necessary additional equipment. Clothing should be comfortable but suited to the job. Most ADSC contractors working on micropile or anchored earth retention sites require employees to wear high-visibility garments such as vests, shirts, or coats. Eye protection must be worn at all times. Face shields are also highly recommended in some conditions. Hearing protection must be used when noise levels reach 85 decibels. A good rule of thumb is if you have to shout to be heard, then hearing protection must be worn. Equipment operators should always use hearing protection. It is very important to inspect drill rigs, grout mixers, and pumps, as well as any other auxiliary equipment on a daily basis. This inspection must be documented to be meaningful to you and your employer. Not only will it help find potential safety issues, but will also provide maintenance information as well. A checklist is the most common format. Drill rig masts, hydraulic cylinders, and supply hoses, rotators, hammers, jaw clamps, auxiliary crane or carousel must be inspected frequently. Pay particular attention to the feed chain and its connection to the drill motor. In addition, inspect the equipment frame and other parts of the structure for flaking paint. Looking underneath may reveal cracks or rust, worn areas, bent components, and other signs of wear and damage. Damaged or worn items must be repaired or replaced according to the manufacturer's requirements. Grout mixers and pumps are key components of the anchor or micropile installation process. Inspect this equipment with the same care and concern as the drill rig. The pumps and mixer must be thoroughly cleaned after use. Ensure the unit is shut down and locked out to prevent unintended startup during the inspection or cleanout process. Remember, bulk cement hoppers are possible confined spaces, so do not enter unless you are trained and authorized to do so. Consult your employer's confined space entry procedures before entry takes place. Before startup, check the fluid levels of all reservoirs. Engine oil, hydraulic fluid, and fuel should all be at the manufacturer's recommended levels. Add fluids with the engine off. Check the condition of the hydraulic and pneumatic systems, the hoses, and their connections. Use extreme caution in repairing or replacing hydraulic hoses or cylinders. The oil is under pressure and may also be very hot. Severe injury can result when pressurized hydraulic oil enters your skin or a cylinder violently moves in an uncontrolled manner. Take the time to properly bleed down all stored hydraulic pressure before working on the system. Consult the operator's manual or the manufacturer for the correct procedures. Verify daily that all guard covers and screens are in place. If you must remove a guard to inspect or adjust, replace it before starting the engine. Use caution around rotating shafts, gears, and other mechanical components. Inspect the control panel and ensure all gauges are operating correctly and the control levers are functioning properly. One control that must always function is the emergency stop. This control must be checked to ensure it actually shuts down the engine or dramatically reduces the rotation speed. And don't forget to inspect the rig's wire rope, winch, and the articulating service crane for any defects or damage. Lubricate the wire rope often. Each rig must have an approved dry chemical fire extinguisher in place at all times. Inspect it daily. Before loading the drill rig onto a trailer, check brakes or tramming controls for proper operation prior to loading and unloading. Load and unload on level and stable ground. Use someone on the ground as a spotter. Use a properly designed loading ramp and know the weight limits prior to use. Distribute the weight evenly on the hauling equipment and in accordance with your permit, if applicable. Use the same care when unloading the drill as well. Before leaving the yard or job site, a final check of the drill rig and its tie downs is necessary. Any items extending beyond the body of the vehicle should be marked with high visibility flags. Some drill rigs may need to be partially disassembled for transport. Follow the manufacturer's procedures completely. Do not shortcut any assembly procedure. Do not substitute any non-manufacturer's parts, fasteners, or components. The use of substituted items may cause a structural failure and cause an injury or possible fatality. Organization and good housekeeping are important to both efficiency and safety. Before any work or unloading of vehicles occurs, several steps are required. First, a site safety inspection must be made. Any potential dangers in or around the work area must be identified. Everyone on the crew must be made aware of the results of this effort. Overhead power lines are killers. In the U.S., contact with an energized overhead power line is the #1 killer of employees working with or around a crane. The same hazard exists with a drill rig. If power lines are near the work area, special precautions must be taken. Assume all overhead lines are live. At no time should any part of a drill rig be allowed to enter the danger zone that surrounds an energized line. The danger zone clearance should never be less than 10 feet and must be increased at voltages that exceed 50 kilovolts. When equipment is being transported or is moving from one work area to another, there are minimum required clearances for transit under live power lines. If you must work closer than 10 feet to a power line, make sure it is de-energized and grounded before any work is permitted. If contact is made with a live power line, the procedure for all personnel must be clearly understood. No personnel should approach or touch the equipment until the power is turned off or the contact has clearly been broken. When working in the vicinity of overhead power lines, all employees must be trained on the hazards associated with this dangerous work environment before work begins. It is a best practice to erect warning lines, signs, or barricades to identify and then prevent encroachment of the danger zone when working near overhead power lines. Warning: moving a live electric line should only be performed by a trained, qualified person. If a person is within an energized zone, they should exit the zone by keeping their feet in contact with the ground. Shuffle one's feet, or move heel to toe until clear of the energized zone. The clearance distances stated are for work in the U.S. For work outside the U.S., please consult your local or federal occupational safety and health requirements for the safe, clear working distances in your area. Before any drilling or other type of excavation takes place, it is necessary to check for underground hazards. Someone from your company must contact the local Call Before You Dig system. Most areas require a minimum of 48 hours or 2 working days advance notice for this survey to take place. Consult your local utility locate service for accurate details and requirements. All underground utilities such as electric, gas, telephone, and fiber optic lines or utility vaults must be physically located prior to starting work. If drilling adjacent to or under an existing structure, make sure that you will not drill into the structure below grade. Check your elevations. Remember, you simply cannot afford to take a chance with underground utilities. The repair costs for damage to a utility can be enormous. The possibility of someone losing his or her life is even greater. So call before you dig. Other dangers the crew might encounter include work in limited space, site obstructions, and the equipment and crew activity of other contractors on the same site. Special attention should be given to traffic whenever work must be done on or near roadways. Most states require posting signs, cones, and even trained personnel if work is to be done near traffic. Do not make the mistake of letting these precautions replace your own safety awareness. Stay alert. The last item to be addressed is an area work plan. To the extent possible, it is highly desirable to keep the job site clear of hazards. This is most effectively accomplished by identifying specific areas around the site for storage of materials such as tendons or cement, truck unloading, fabrication, and other major space requirements. Then you need to address the actual overall installation plan and address any issues that pose a hazard or conflict. It is in everyone's best interest to know and observe the area plan. After the site inspection is complete and all crew members have been briefed, preparations can begin for drilling. Anchor and micropile drill rigs must be set up and worked from a level and stable platform. This is true for grout mixers and pumps as well. You may need to simply grade the area with a loader or dozer, or place crushed stone or crane mats to better stabilize the location. The time you invest in keeping the worksite dry, stable, and level will pay for itself in the long run. Before the drill rig can be set up, specific authorization from the supervisor should be given to the operator. This should only be accomplished after ground conditions are checked for support capability and notification has been given to the crew that the rig is about to be set up. Ground support is critical to rig stability. If the potential for caving soil exists, pads must be placed under outriggers if your drill rig is equipped with them, or crawler tracks to ensure solid support. If the ground support is not sufficient to ensure absolute rig stability, the probability of a catastrophic accident is high. Never underestimate ground conditions. If your track-mounted drill rig has retractable side frames for transporting, do not tram or operate the drill without the side frames fully extended. Consult your operator's manual for this process. Operators must be aware of the presence of all ground personnel in the immediate vicinity of the rig before moving it. A spotter should be designated to ensure safe movement of the equipment. The operator and spotter should make sure no personnel are in the path of the drill rig when it is traveling or during setup on location for drilling. Blind spots around the rig do exist. If you cannot see the operator's eyes, they cannot see you. It is critical that all personnel be aware of the risk involved with being in a blind spot when working near operating equipment of all types. Falls account for 33% of all deaths in the construction industry. The use of fall protection may be necessary when installing a micropile or tieback anchor. For example, rock anchors may need to be installed on an existing rock face in need of stabilization. The use of a crane-suspended drill platform may be the safest method to perform this task. However, the employees involved must be fall protected any time they are elevated over 6 feet in height. Before attempting this procedure, you must consult with your local, state, or federal safety regulations to ensure you are in compliance and are performing the task safely. Tiebacks are often necessary to retain steep slopes or repair existing landslides. Oftentimes, the working bench is very narrow and may expose employees to a fall hazard at the edge of the bench. Ensure the employees are fall protected at all times using appropriate personal fall prevention protection methods such as full body harness and retractable lanyards or a handrail system. In the U.S., the requirement of an anchorage point for fall protection must be capable of supporting 5,000 pounds per employee attached, or shall be designed, installed, and used as part of a complete personal fall arrest system which maintains a safety factor of at least 2, and must be under the supervision of a qualified person. Note: countries outside of the U.S. may have different fall protection requirements. Access to the actual drilling locations may be a challenge in itself. There are numerous types of drill rigs available to reach these difficult environments. One major concern is operating an internal combustion engine inside a potential confined space, such as a parking garage, basement, or a deep, small excavation. Carbon monoxide is a deadly gas and can build up quickly if adequate ventilation is not available. You should constantly monitor the air quality to ensure a safe working environment. There are numerous types of drill steel and tooling available for use when installing a tieback anchor or micropile. Ensure the tools and drill steel sections are compatible with each other. Do not force components together. You may damage them initially and then get someone injured when it's time to take them apart. Down-the-hole hammers require periodic inspection and maintenance. They typically require some form of lubrication, as compressed air is passed through them. Some hammers operate using pressurized water. Know the type of hammer you are using and operate it according to the manufacturer's recommendations. There are numerous manufacturers of hollow bar tendons. They come in various diameters and lengths, but are not interchangeable with another manufacturer's product. When this product is used, the hollow bar becomes the drill steel. As you rotate and advance the hollow bar into the anchor, grout is continuously pumped until the anchor is drilled to design depth. If you are manually handling drill steel, casing sections, or hollow bars, you must be very careful. The sections are heavy, round, and smooth, making it difficult to grasp them firmly. Some sections may require 2 employees to lift and carry them. Additionally, they become wet with mud and grout, and may even become very hot, adding to difficulty and danger. Always wear the appropriate gloves when handling drill steel, hollow bars, or casing sections. When placing or removing the tooling, do not stand on the drill rig to gain height. Use a step, bench, or other stable support to ensure a non-slip surface for access. Even if the carry distance is short, walking with drill steel can be dangerous and requires your full attention. Keep the work area as dry and level as possible. Not only will it be a much safer working environment, it will also increase productivity. A clean site is a safe and productive one. Before placing the section into the drill string, ensure the rotator is retracted to a sufficient height and the operator has indicated to you that you are clear to insert the section. On a tieback rig, it may be helpful to place a spacer block on the mast to prevent a crush injury in the event you lose control of the drill steel section. You can easily crush fingers, break bones, and possibly amputate your fingers if your hand is caught between the drill steel and the mast. Once the section is coupled together initially, the spacer, if used, must be removed. You must indicate to the drill rig operator that you are clear of the drill steel before the sections are completely threaded together and drilling continues. You must keep in constant contact with the rig operator and keep clear of the rotating drill steel. Failure to stay clear of the rotating drill steel or casing may result in amputation and other severe crushing injuries, and possibly your death. Do not wear loose clothing like unbuttoned sleeves or shirts or unfastened safety vests when working with the drill steel. You must always remain clear of the steel and always ensure the operator knows of your whereabouts. Constant communication with either voice or hand signals is a must. An alternative to manual handling of drill steel is to use a hydraulic grapple or automated drill steel carousel to load or remove drill steel sections. Note, depending on your geographical location, the use of a guard which covers the rotating drill steel may either be required by law or your employer may choose to provide this additional protection. Regardless of the methods used, you must always remain clear of the steel and always ensure the operator knows of your whereabouts. Constant communication is a must. Many drills have hydraulic jaw clamps to assist in breaking the threaded joints apart. Never place your hands near the clamps during drilling or extraction of drill steel sections. If you must use wrenches to break drill steel or casing, use extreme caution. This operation is very dangerous and can severely injure the helper. Never hold the wrench with your hand. Always hold tension on the wrench using an attached length of rope. In the event of a mistake, this will keep some distance between the mast and the rotating section, a very dangerous pinch point. Today, Many drill rigs are equipped with an auxiliary crane to assist in handling drill steel. If equipped, you must inspect this crane before each shift. Check for hydraulic oil leaks and general damage or wear. Ensure the boom sections telescope freely and that the unit will swing and not bind up during rotation. Inspect the hook and ensure it has a functioning safety latch. Remember, do not overload the auxiliary crane or use it for pick and carry procedures. It may fail and cause injuries. If your drill rig has an auxiliary winch to handle drill steel, it must be inspected. Look for hydraulic oil leaks, damage, or wear to the wire rope and any sheaves it passes over. If the wire rope has a hook, inspect it to ensure it has a functioning safety latch. There are typically 3 types of rigging used when installing micropiles, tieback anchors, or soil nails: synthetic web, chain, or wire rope slings. Synthetic web slings usually provide a more secure grip to round, smooth drill steel, but wear faster and are most susceptible to damage. Whichever you choose, ensure it is of the correct capacity for the load, and remember, always inspect your rigging before each use. Hand signals must be clear and understandable by all employees involved when using a crane for lifting material. When lifting any load, it is essential that one qualified person be responsible for giving all signals to the crane operator. During the entire lift process, this individual must have absolute authority and no distractions. While your drill rig may have the ability to use percussion as well as rotation when driving casing, it may not be designed to extract casing when in percussion mode. Consult the operator's manual or the manufacturer for accurate information. Severe damage and/or injury may result with improper use. If you are using electric-powered tools, you must keep your power cords high and dry and not allow them to lie in water or muddy conditions. You must protect yourself by using a GFCI or ground fault circuit interrupter plugged in at the power source. Today, many portable generators have GFCI protection built into their power outlets, but not all do. A circuit breaker alone will not protect you from shock or electrocution. A fully inspected and properly maintained tool, power cord, and GFCI will. Compressed air may be essential to drill rig operations. For pneumatic-powered equipment, an airflow reduction valve should be installed at the air compressor outlet. This device will shut down pressurized air moving through the line if there is a blown hose, broken connection, or fitting, almost immediately. Consider 900 cubic feet per minute of compressed air at 150 pounds per square inch flowing through a 2-inch diameter hose only 3 feet away from you. You see why this device may save your life. Once again, secure all supply hose connections with either a whip check or a whip sock. The environment plays a big part in worker safety. Proper work clothing is essential for all seasons. Dress in warm layers during the cold winter months and wear light-colored clothes in the summer. Remember, the use of sunblock is strongly recommended all year long, as the sun can damage your skin and cause possible skin cancer. Rain gear is an obvious choice if it is raining, but it may also keep you dry if you are drilling with water or encounter groundwater or are mixing grout. Good lighting is essential if you must work after sunset or in an enclosed structure. Place the lighting in such a way that it provides adequate illumination but does not cause dangerous blind spots or shadows. During the course of installing an anchor or micropile, it is possible to encounter existing contaminated soils or water. The contamination may not have been noted on any of the soil's reports, so you must be prepared for such an event. If you encounter strong chemical odors or notice a dramatic change in color of any groundwater or soils, you should stop drilling and notify your supervisor immediately. If possible, move away from the drilling location and set up at another. The potential contaminated material must be analyzed to ensure it will not harm you or your coworkers before you return to that location. Drilling through concrete, a few soils, and most rock will generate some amount of dust. Within this dust, it is highly likely there will be particles of silica. Exposure to silica dust is hazardous to your health. Warning: fortunately, there are several methods you can use to control dust exposure when drilling. Mechanical dust collection using shrouds, suction, and filters is one method. Water misting the dust as it exits the borehole is another method, as is injecting water through the drill steel as drilling takes place. You must choose an appropriate method for your site conditions. The dust not only can affect the drill operator and helpers, but all employees downwind as well. So please, control the dust. If it is necessary for employees to use a respirator to protect them from any dust or other contaminants, the user of the respirator must have passed a medical evaluation questionnaire, be fit tested for the respirator, and receive training on its correct use by the employer. Once the anchor or micropile is drilled, some form of tendon or reinforcing steel must be inserted into the borehole. The material may be inserted through the casing or may be inserted into the open borehole. The material may be one of several types, including strands, hollow bar, threaded bar, fully encapsulated, and/or epoxy-coated. The tendon material is selected during the design stages for the project, depending on the loading it will be exposed to. Each manufacturer provides an assortment of connectors and anchorages for their respective products. While they may look similar, you must never use components from one manufacturer on another manufacturer's product. Consult the manufacturer's information for the correct use of hardware and components for your project. Inserting the tendon may be performed by hand. This method requires multiple employees to not only handle the weight of the tendon, but to also keep the tendon free of contamination such as mud as it is inserted into the borehole. Larger or longer tendons may require the use of a crane or uncoiler to safely insert the tendon. When mixing grout, only experienced personnel should be used. Not only is quality control important, so is working safely around the mixer and pump a must. These employees must be trained on the safe inspection, maintenance, and operation of the mixer and pump. Set the mixer and pump in such a way that they are level and secured from movement. Always follow the manufacturer's operation manual for correct setup for your equipment. The mixer and pump must be set up as close to the work area as practical. This is not always possible and may require many lengths of grout hose to be strung out. Keep the hoses away from construction traffic and from causing trip hazards to employees in the work area. All supply hose connections must be protected by whip checks or whip socks. When mixing and pumping grout, a number of potential hazards exist, depending on the methods used. Place all bagged material used in the grout mix as close to the mixer as possible. A typical bag of cement weighs 94 pounds, so it is a good idea to stack this material at least waist high to avoid bending over to lift it. Make sure the material is stacked so it will support itself. Use proper lifting techniques when lifting the material bags. Wear all appropriate PPE, hard hat, safety glasses, rubber gloves, full-length sleeves, and respiratory protection when mixing grout. Cement grout is caustic, meaning it may burn your skin. Wash off any grout that splashes onto your skin as soon as possible. If any grout gets into your eyes, you must immediately flush with clean water or eye wash solution. Medical attention may be required to completely remove any remaining foreign objects and treat any damage to the eye. If a bulk grout mixing plant is used, the employee involved with its operation must go through more detailed training about the unit's operation. Many plants operate using electric power, and as such, proper procedures must be adhered to in order to prevent electrical shock injuries. Most manufacturers of this equipment offer on-site training for the employees. Take advantage of their expertise for a safe and productive operation. Good housekeeping is a must around the grout mixing and pumping area. Pick up empty bags and containers and dispose of them properly. Stack empty pallets out of the work area. Keep the work area as dry and level as possible to avoid slip-trip injuries. Most mixers either have rotating paddles or impellers to mix the dry and liquid materials together. Under no circumstances are you to place any part of your body inside the mixer while it is running. If you must do so, shut down the power supply to the mixer and bleed off any residual pressure and secure the unit from startup before making any adjustments or repairs. Ensure the unit cannot be restarted while you are working on it. Most grout pumps have many moving parts. Any exposed moving parts must be guarded to prevent accidental contact. If the guard is removed for repair or maintenance, replace as soon as possible. If the equipment has inline lubricators, make sure they are inspected to ensure that they are functioning and are filled daily with the correct lubricant. Never open a lubricator unless the compressed air supply has been shut down and the residual pressure has been bled off. Use caution when blowing out a supply hose, either during washout or when removing water in an effort to keep the water in the hoses from freezing. Do not point the end of the hose at any employee or equipment, and secure the end from whipping uncontrollably. Warn other employees this procedure is about to begin and clear the area before blowing out a hose. Pumping grout may be performed under low or very high pressure, depending on the type of anchor or micropile you are installing. Pumps can generate very high pressures. Make sure all hoses, fittings, and regrout hardware are rated for the pressure capability of the pump and protected by whip checks where applicable. Secure all grout tube fittings and couplings correctly, using the correct glue or clamps. Make sure the pump has a pressure relief and that it works. Check the pressure relief daily. There is always the possibility that the grout pump or supply hoses will plug up during pumping operations. A plug in the line may be caused by a number of problems. It may be caused when starting to pump by a lack of lubrication in front of the grout as pumping begins. It may be caused by dirty hoses that were not properly cleaned on the previous day. If plugging conditions in the pump or hose occur, do not attempt to use power to correct the condition. Reverse the pump or release the line pressure, determine the cause of the plug, and then correct it. Remove the plug. Reassemble the system using gaskets, clamps, pins, and whip checks. Then resume pumping. Trying to force material through under jammed conditions may result in serious injury to people or damage to the pump or hoses. Pulling tension, tensioning, and stressing are interchangeable terms describing the application of a stretching force on the tendon. Under ideal conditions, this is a safe operation. However, in the real world of anchor or micropile installation, the conditions are typically anything but ideal. As with the drilling equipment, the manufacturers of the tendon material have established guidelines for the safe handling and tensioning of their products. It is a must for all employees involved with this operation to read and understand the manufacturer's information. Prior to tensioning the tendon, ensure the work area is as dry and level as possible. Since tendon material is typically made from high-strength steel, caution must be used when welding near or cutting this material. If any type of welding operation must take place near the tendon, you must first insulate the tendon material from the welding arc or splatter. Do not use any part of the high-strength steel as a ground connection for welding. Never pass an electric current through a tendon. This can change the molecular structure much like heat does, and result in a failure of the tendon while stressing it. Extra care must be taken to ensure this does not happen, especially when welding wedge plates and/or whalers. Insulate the tendon from any contact. Accidental stray contact may damage the tendon and possibly cause it to fail during the tensioning operation. If stressing a strand-type tendon, make sure the strands are oriented correctly. No individual strand should cross over another as they exit the drilled anchor. If the strands are not aligned correctly, they may bind up or cut one another under tensioning and may fail. The stressing ram typically requires 2 people to set it up on a tendon. This is especially true on a strand tendon. One person must hold the strands to allow the ram to be placed over them. The same is true during removal. If the strands are not held, they can whip around and cause severe injuries. Use proper lifting techniques if manually lifting the ram. There is a difference between oversized nuts and left and right hand threaded nuts. Oversized nuts are made specifically to thread onto an epoxy-coated bar tendon and take into account the thickness of the epoxy coating. Warning: an oversized nut will thread onto a bare thread bar but will not hold the required load. There are left-hand threaded bars and right-hand threaded bars. Each has a different rated strength. Do not attempt to force a nut onto a bar as it may be cut opposite of the nut. Consult the tendon manufacturer for strengths and sizing. Don't guess. Make sure all hydraulic hose fittings are cleaned and the connections are tight on the tensioning equipment. The hoses should not be kinked. If an electric pump is used, a ground fault circuit interrupter, GFCI, must protect it. Do not use a cast iron anchor head in front of the ram to tension a strand-type anchor. A steel stressing head supplied by the strand manufacturer is the only type that may be used for this operation. The cast iron anchor head may break during tensioning and may cause a serious injury. Use the manufacturer-supplied stressing wedges in the steel stressing head and supplied lock-off wedges in the cast anchor head. Clean and inspect the stressing wedges after each use, as they are reusable. Discard the wedges when cracks appear that are longer than 12 threads or at the manufacturer's recommended intervals. Several different loads will be applied to the anchor. After each load is applied, a reading will be made from the dial indicator. Always position the dial indicators or other form of measure on either side of the ram. Under no circumstances is anyone to be in front of the anchor when stressing is in progress. Some micropiles are tested in compression as well as in tension. A compression load test must be set up correctly, with care given to the testing frame and its accessories. The frame should be set up level and accurately placed over the micropile to be tested. Once again, the precautions regarding the use of the hydraulic ram, reading instrumentation, testing hardware, and the test frame setup are very similar to those for testing a tieback anchor or soil nail. Regardless if you are working on an anchor or micropile job, safety must control every aspect of your thoughts, both at work and while at home as well. On-the-job safety can be a matter of life and death. Yes, the demands of a tight schedule and project budget are always present, but they simply cannot outweigh the need for continuous project safety. Quality control, productivity, and safety go hand in hand. If you sacrifice one to obtain the other two, you have accomplished nothing. Working safely increases productivity and quality control because it forces you to plan your work correctly. You are responsible for safety. So remember, life is a gift. Don't throw it away by accident.
Be safe, be careful, and let's all go home happy.